and Raj. Yeah. Going to be a presentation by Vladimir Alexiev from Ontologies and Bulgaria. Then Vladimir will follow, Vladimir from the University of Malta. Yeah. And then a presentation by us at Qatar on our we are still within the theme of methodologies, data visualization and textual analysis. And Vlad's presentation is going to be on museum-linked open data, ontologies, datasets, and projects.
Hi everyone. So I come from a software company and we're working on semantic web technology. So here's basically the outline. I guess the presentation will be put somewhere on the on a website of the conference, and I have quite a long report on these topics that was published in a Bulgarian conference on digital preservation. So if you're interested in these themes, here is the link. Also, if you look for my publications, you can find it from there. So I'll first say what is linked open data and give some practical examples, and maybe even give a bit of a demo of one such data cloud, Wiki Data, and mix and match and how all this works together. And then basically talk about on-to-text projects in this regard. I think that semantic technologies is a bit of a unfortunate name because people think that it has something to do really with, you know, deep meaning of information or even philosophical questions like what are these ontologies. And I think that the essence of semantic technologies is in interlinking things. So initially when it started, it was dominated more by people in mathematical logics. But few people used the capabilities, for example, of OWL2, the web ontology language, like in-depth reasoning and stuff like this. And when it really took off is when there was a change of direction towards linked open data. And the basic ideas is that every little piece of data, you make it individually addressable. So it can talk not just about the person, but about the very specific circumstance of that person. Like where he was born and who says he was born there, and are there other opinions? What is the provenance of this one statement? And the other thing is this maxim things, not strings. In other words, when you see John Smith in a museum collection, what does that mean? There could be thousands upon thousands of John Smiths, and it's better to reference something in a global data set like VF. So where did this thing come from? Well, it came from the same guy who invented the web, or as they call it, Web 1.0, is the web of documents that we know, web of web pages. And then this semantic web is Web 3.0, and you see that even on the original proposal at CERN, there isn't only documents in the web, there is machines, there are people, there are departments, and so on and so forth. And this is the guy, Sir Tim Berners-Lee. And let's take a look at what Wiki Data, which is one node, one of the important data sets in the Link Open Data Cloud, even though it's not the biggest, it's not the first one. And this here is an application called Resonator. And you see that we have his name in a bunch of languages. We have a machine-generated short biography. We have information about his family. Here on the right side, we have a whole bunch of identifiers of this guy in other databases. You can see them, there's maybe 50 of them. And then information about his awards. The reason I mention awards is because one of the projects we're working, called Tracking of Research Results, has to do with knowledge graphs of science. So we're looking at awards, memberships in learned societies, papers, and so on. Now let's show you this more from a culture heritage perspective. So we did work for the Canadian Heritage Information Network, and this is a very well-known Canadian artist, Emily Carr. Again, you see here her biography. On the right side, a whole bunch of IDs in other datasets. Here we have a list of her paintings. It's not that many, it's like maybe 25 that Wiki Data knows about. And here odds and ends, and these odds and ends. Should we maybe merge these two items, right? Because the title is the same. I thought of merging them, but then it also pops up the image, and no, these are two different paintings, just same name. So these core references, where do they come from? Well, there's this excellent thing called mix and match. It's not part of Wiki Data, the dataset, but it is one of the many tools that people use to put data in there and correlate. And if you search for Emily Carr in mix and match, you see all these different datasets. So the first one is Art UK. Second one is RKD, that is the Dutch Art Institute, and so on and so forth. And you see here on the right that many different people contributed to those matches. Some are automatic, right? But some are made by, or an automatic match was vetted by a person. And this is how Wikidata grows. This is how the knowledge grows. There is maybe 2,000 catalogs in mix and match. These are snapshots of external databases, and people use them to interlink data. So I've shown here the Academy of Europe member list that we currently worked on and completed. These are 4,000, maybe the most important researchers in Europe. This is like a high-level learned society at the European level. But there is also a whole bunch, I mean, if you scroll down the numbers here, you see various groups, people. There's 500 data sets on people. And then if you look further down, there's biographies, another few hundred, and so on. We've put in here the Getty thesauri. You see later in the slides, we worked a lot with the Getty. So you have the Getty Museum person IDs, okay? And then you have ATTG, and you also have ULAN. It's just that in the description, I guess it didn't say in the catalog, this comes from the Getty. Now, if you take a look at the AT, for example, so it has about 40,000 concepts. Perhaps you know that this is a very important thesaurus in art and architecture and related sciences. And 18,000 of them are matched and manually vetted, so these are high quality matches. But there is 22,000 more to go. Unfortunately, these here are the harder, I mean, the easy fruit has been already picked, so these are the harder cases where you really need to dig and find whether this is that or whatever. To give you an example, so here I've made a report of some discrepancies, like for this here entity which relates to 180 concept, there are two entries for hornpipe. And the reason is that one of them, the first one in capital, I would suspect this is the wrong one, because the 80 is on thesaurus of concepts, not of instances, not of individual things. So hornpipe, this first thing, is a DAS, okay? Whereas I would think that they mean hornpipe, the object. So we could go and, the instrument, right? So we could go and fix this. Or further down you have horn and horn. Well, one is the anatomical feature on an animal, the other one is material. And I would guess the Getty has both of those. And one can quite easily go and fix such kind of things. Or take a look at one of the matches in the Getty, neoplastic versus the steel. So how did it know to match? I'm sure that this lady, Mistress D, not my mistress, I don't know her personally, I doubt that she did this match. I think that it was an automatic match and she just checked it. And well, it's easy to open this and to open that link. And we see here the steel, it is a Dutch movement and also an art magazine, neoplasticism, right? So it is feasible that that is the same thing. And if we look at the Getty, here we see the same label that appears in Wikidata. So these systems, they're very good at matching thousands of labels across and trying to find the correspondence between things. And let's contribute a bit to Wikidata. So one of the entries was about the Geotech language in Mexico. And now this here is in Tagalog. TL is Tagalog. I'm using the translated version, okay? this is how Tagalog is written. I don't speak Tagalog, so I use Google Translate to figure out what it means. But there already is another set of entries for the Tagalog, for the Yucatec language. You see here the links. So there are something like 10 pages in Brazilian and in English and so on. So what I want to do is merge up these two entries. This here, the Tagalog entry of this language, belongs together with all of those. I grab the ID, I go here, merge, you enter the number, and it just goes and merges the two entries. Okay, so now we have the Tagalog wiki page about that language together with all the others, and that is linked to the Getty, and you see how this network of connections emerges, right? Okay, I'll have a bit more. I have a few Wiki Data queries, but let me proceed with the presentation. So, linked data is about something that became very modern in the later years, knowledge graphs. And I think Google popularized this term. So internally, Google has knowledge graphs, which allow it to make a distinction. When you write Jaguar, it tells you, or it asks you, but do you want the animal or do you want the car? And if you pick the animal, then it's going to tell you, okay, there's also these other related animals. So it has things, it understands the meanings of words to some extent, and it has connections between these things. And people make all kinds of graphs. We've worked with Springer Nature for their science graph. Thomson Reuters put out a free graph of companies. Microsoft Academic Graph, that's a huge thing. 120 million publications. Okay. And this is a very interesting report. I highly recommend it. It came out just a couple months ago. Okay, now on Wiki Data, they have a lot of information about art and paintings and so on. There's a project called the Sum of All Paintings. And if you look at paintings with image, there's over 100,000, and this data is old. I mean, there's probably now 150,000. That still is very small. The Getty Museum itself has 800,000 objects. The British Museum has 5 million and so on. There is also information in Wikidata about other works of art, like publications, audiovisual, and so on. So works of art, 1.4 million. But my query was only the ones that have an image. And they can only have an image if the museum is okay with publishing it under CC0 on Wikimedia Commons. Or take a look at institutions, 360,000, of which GLAM institutions 63,000 and so on. That's still small. I mean, only libraries in Canada is about 6,000, and Wikidata doesn't know about many of those. Okay, now a few words about OntoText. We've been working with these sort of technologies for 19 years now. We're part of Sirma Group Holding, which is a large Bulgarian software company on the Bulgarian Stock Exchange. We are now having a greater role within Sirma Group because it turns toward cognitive computing. That is the development strategy of the group for the next few years. So hopefully more companies from the group will use cognitive and AI and big data. This is a list or a timeline of research projects of OntoText under the European research programs. So OntoText is often given as an excellent example of a company doing research. We have more research projects than most of the Bulgarian universities, except the top 2 or 3. And we have projects in a wide variety of domains: company data, culture heritage, fake news, rumor detection. Life sciences is a big consumer of semantic technologies. So now a few words about the currently active research projects that we have. I'll just mention a few of them. CIMA is our first project with Bulgarian national funding. It's about linking of company data, and that is a big priority for us because we have commercial projects in that regard. Cleopatra is just starting in our first project in Maria Sklodowska-Curie Action. So we're going to take some PhD interns from this network and apply them to commercial projects. Tracking of research results is a very interesting project. It is for the Ministry of Science of Europe, and it is to find out the impact and the output of FP7 projects. And we verify on false news. Is the first project that Ontex is coordinating. So usually in those projects, Ontex takes the technical role. Semantic data integration, data cleaning, interlinking, storage, reasoning, querying services, and semantic text analysis. And finally, this one is quite interesting. Just like in Holland, Clarin and Daria, which are the European research infrastructures for language heritage and for cultural heritage or digital humanities. The same is happening in Bulgaria. So we are a part of that network. More specifically, research culture heritage projects that Ontex has done. So we started with Research Space, which is led by the British Museum. I have a few slides on that. And then Conservation Space is well, research Space is funded by the Mellon Foundation. Conservation Space is the same, but they're very different in terms of approach. Conservation Space, I think, is a lot more successful. Europeana, we have done 2 projects, Europeana Creative and Food and Drink, and also we're quite active in the network, Members Council, data quality. For the Getty, we did the link open data publication of the Getty vocabularies. Carnegie Hall, about 8 months ago, put out linked data of all of their performances, musical styles, performance, and so on and so forth. And they use our semantic database. American Art Collaborative, that followed these leads of the British Museum and Yale Center for British Art and the Smithsonian American Art Museum. So these are 14 museums that interlink their data using linked open data, and we did consulting. European Holocaust Research Infrastructure, there is semantic integration of archival collections, and it's a very difficult problem there because the majority of those victims, and there were at least 15 million victims, they weren't famous, they're not on VIAF. I mean, you often don't know a lot about them, so how can you interlink them? And we're trying to do their virtual family reconstruction and stuff like this. And then we did consulting for the Canadian Heritage Information Network, which is transitioning the national aggregator to link open data. And we're active in Wiki Data, DBpedia, and I mentioned already the Bulgarian CLADA. So the sort of work that Ontex does, we have a semantic database, or what's called a triple store, called GraphDB, because the semantic data model is really a graph data model. You have nodes that are connected by links. And we applied to master data management, to information publishing. We have clients like the BBC and the Financial Times, so publishers that want to index their content and reuse pieces of content and provide recommendations, smarter searches. So we also do a lot of semantic text analysis, named entity recognition, automatic document classification. This here is a quick example from our GraphDB database. So we have it's a database, nothing too much exciting about it. Maybe this is a bit more interesting. The previous lecture mentioned OpenRefine. We've integrated OpenRefine into GraphDB. It's an excellent way to work with sheets, tables, to clean them up, and then to publish them as semantic data. Okay, and now a bit more details on culture heritage projects of Ontex. So the first one we did with Europeana was Europeana Creative, and 2012 until maybe 2015-16, we kept the Sparkle endpoint of Europeana. Until that point, there was the Europeana API, but with the API you cannot do stuff like this. For example, this is count of newspapers by year. Someone here is working with Europeana newspaper, so there's many hundreds of thousands. You see here that for this decade, there is over 100,000 issues. And the reason you cannot do queries like this with the API is because it is fixed. It can search, it can return data, but you cannot tweak it, and it's not a generic query language to tell it, just give me the numbers broken down by decade. And Sparkle, the semantic query language, works for that. We also created an OIPMH server, so you can pull Europeana data in book. This is a typical Europeana object. It is a simple graph model, a central node, and then 4 peripheral nodes on the site. Another Europeana project was food and drink. So as part of that, we did a semantic search application. You see here 2 facets that are hierarchical and semantic, meaning that here this is a geographic facet taken from geonames. So we even had, a few from Antarctica. Someone had the bright idea to go and get penguin eggs from Antarctica and sell them in supermarkets. That didn't work out very well. And this here is a food and drink topical gazetteer that we extracted from Wikipedia categories on food and drink. Then the British Museum Research Space project. So it's a virtual research environment for art research. The problem is that it didn't have very well-defined requirements of what really an art researcher needs in his daily work, unlike conservation space, which started with 3 years of requirement gathering. And as part of that project, we did, it was one of the first large-scale projects to convert real museum data to CDOC CRM. This here is the famous or infamous diagram that the project manager, Dominic Oldman, shows and compares it to the relational schema and says, see how much simpler semantic data is? Well, it didn't work out quite well because you need to break it down into much smaller pieces and simplify and make it more accessible. It's an interesting and difficult problem how you do semantic search over such an elaborated network of information. So there is an approach called fundamental relations and fundamental concepts. Basically a complex network like this, which indicates that the thing is associated with a place. Either it was made in the place, or part of the thing was made in a place, or it was made by somebody born in the same place, or somebody who lived or did his work in that place. So you could compress a long semantic network like this into just one relation to facilitate search. And then you could do search like this, kind of like in a sentence. And because it is, this here uses a thesaurus, the British Museum thesaurus of subjects. And so I'm searching for mammals, but it knows that horses and pigs are mammals, and this here even is a lion, right? So you can find documents indexed by the sub-concepts if you search for the super-concept. That's called query expansion. It also used the open annotation ontology for annotating particular parts of images using deep zoom and SVG annotation. This here is the next Melon project, conservation space. It's quite successful. It's deployed in something like 15 institutions by now, and there even are master's programs in conservation that use conservation space for their practical work. It has deep zoom, documents, many complex things that a conservation needs for his work. The next project I want to describe is the European Holocaust Research Infrastructure. We did a lot of work there with Thesauri and trying to harmonize and do some semantic text extraction from EAD descriptions of archival units. But I just want to show how we use Wiki Data. So the previous EHRI 1 project had produced a very short list of camps and ghettos. And I said, well, take a look in Wiki Data and Wikipedia, there's a lot more. So let's use that as a platform of data integration, do our data work in there, and then ingest it back. Because in Wiki Data you have geographic coordinates of places. So if you relate to where this camp or ghetto is, then it becomes a lot easier to get richer data. And so what we did is, before we started the EHRI work on camps and ghettos, this was the map of camps and ghettos on Wiki Data. And after we contributed the ghettos, this was the map. And I have a query here showing also the camps. Okay, so these are concentration camps. They're not only Nazi camps, there are camps all over the world. And the way this works, you see how simple the query is? Of course, that's gibberish to anyone who isn't used to it, but if I hover over a term, it tells me what it is. So this P31 means instance of. So I'm looking for items that are concentration camps. The first hop is it should be an instance of, and then this here means well, either a concentration camp, this item Q1520 whatever, or a subclass of that. And the way you write it, actually it's not, I mean, I don't know the 3000 Wiki Data properties by heart, but there is auto-completion. So let's say this item, how do you enter it? You write WD concentration, and then you press Control Space, and it finds the item for you, okay? And let's say I want to get the geographic coordinates. You cannot make a map without coordinates. So you go like this. For the item, give me the property coordinates. Okay, coordinate location, that is what I need. And then you see here that with this little comment on top, we tell it to make a map. Previously I showed you an example of paintings. Well, this here query is similar, but it says give me paintings within the J. Getty Museum. Okay, so this is the generic search for paintings with images. And if I add here, but I want items where the collection, right? The collection is the Getty Museum, right? Then it only finds the ones that are from the Getty. And then this here painting caught my eye just because it's white, okay? So Giovanni Battista Luzieri. I searched for paintings by Giovanni Battista Luzieri. Turns out that it's the only person of that name, Luzieri. And Wikidata knows only about 3 of them, and only 2 of them have a location. So you see this is the one that we looked at in LA at the Getty. And there is one right over here somewhere in, okay, right here at the Benaki in Greece. I mean, you can do all kinds of queries for basically a catalog zone of somebody's works, and you can investigate the subjects of those works. It's quite a productive environment. Okay, so the next project I will spend a few minutes describing is the Getty linked open data. And this here is a so-called LOD cloud diagram. In this case, an LOD cloud for cultural heritage. It wasn't done by us, it was done by Michel Hildebrand of the Netherlands. And you see the central node that the 3 Getty vocabularies have in such a cloud. I mean, many people use them in their own cultural heritage data. So we've been working with the Getty for 5 or 6 years. And we published the Art and Architecture Thesaurus first in 2014. And we've been supporting the use of those vocabularies for quite a long time, basically until now. It has a lot of details about the semantic model and why it is the way that it is, and sample queries and so on. And many people take it as a good example to follow in culture heritage publications. So this here is the custom ontology that we did for them. I'm a deep believer in reusing ontologies. So this uses something like 10 existing scores for thesaurus, scores XL for representing labels with provenance. But we also had to map out the Getty associative relations. And I didn't write these properties myself. We used an Excel sheet and experts from the museum put in the information, or actually we got it from the Oracle system, and we transformed it to a semantic representation. I'll skip this. These are just some technical details about how the presentation goes. There's very comprehensive documentation, over 100 pages. There's also a lot of sample queries, over 100 sample queries. And here's how it looks in practice. So this is the document. There's a lot of illustrations. I believe that's very important because we're talking a graph of data, right? And here's how the sample queries work. So they are broken up into sections, and let's say places by type. You go here, you click this button to copy over. So we are now going to find republics. Afghanistan, I didn't know that's a republic, but oh, the Boer republics. Oh, that's a democracy. Yeah. And the final project I'd like to mention, I'll skip about the American Art Collaborative. It was a very interesting experience, but also a bit painful because the AAC didn't pay enough attention and effort to define how they want to map data. But these were 14 museums that represented their holdings as linked open data. And it's a sizable collection, 230,000 paintings by 28,000 artists. They linked all of these artists to ULAN, so now you can search. You basically have cross-collection search within that website. But as triple store collections go, that's not very big. 50 million triples sounds a lot, but actually the British Museum data, when we converted their data, it came to just under 1 billion triples. And in life science, we have data sets that are 15 billion triples. Out of this came the linked.art initiative, or CDOC-CRM profile. So in other words, this is a simplified way of using the CDOC-CRM that is more accessible to museums, that is pushed very strongly by Getty's semantic architect. And the best feature is all of the examples that they have on different types of objects. And really the last project, the work that we did for the Canadian Heritage Information Network. So first we wrote a strategy, and a 4-year plan of how they could go about re-implementing the national aggregator using linked data. And then we did an environment scan of projects, ontologies, and so on. So this report of 70 pages is kind of like an excerpt from this report we did for Canada, which you see here, 92 figures, a lot of illustrative material. And then we did an analysis of the current state of Artifacts Canada, which has about 5 million objects collected from 5,000 institutions. So in a sense, it is a mini Europeana. And we helped them with publishing the Canadian catalog of the Canadian thesaurus of object types called nomenclature. And this will come as linked open data next year. And then we did a semantic training, and it was quite a comprehensive affair. So you think that on one of the topics here, semantic data integration, these are the things that you need to take into account when you're producing data. What is the status of the incoming data? How are you going to harmonize the representation? How are you going to validate data and so on? Okay, thanks.